Suppose this time you want to go from point A to point B, or maybe I should say corner A to corner B and back. You want to make a round trip, but you don't want to cross any corners twice other than point A. So you want to go from A to B and come back a completely different route, not crossing any corners twice. So what's a necessary condition to not be able to do that? Well, let's look at your first move. When you're at point A, you can either go up or you can go to the right. And then right before you get to B, you're either at this point or you're at this point. If you're here, then you go to the right, and if you're here, then you go up. So we know where we start. When we start, you either go up or to the right, and right before you finish, right before you arrive at B, either you have to go to the right or you have to go up. There's no other way of getting to B from the step before arriving at B. Now, so let's suppose that you're going to go up first. I maintain that when you get to B, you have to go up if you're going to cross. So we're talking about what it takes to cross. If you go up, you have to cross. Okay, so what am I saying? I'm saying that if you go from point A to here, and then to here, when you come back, you're going to have to cross. Because no matter which route you take, providing that you go up from this point here, when you come back, you're gonna have to cross that red line. There's no way, or at least go along it. There's no way to go from B to A without crossing the red line, or at least being on it. Okay, I mean, if I followed the red line all the way down, I wouldn't be crossing it, but I'll be on it. There's no way to get to B. And it wasn't because of the route that I took, providing that I am going to go up from this point. No matter which route I take, if I go this way and then go up and across and then up, and then from here go up to B, there's no way that you can come from B back to A without going to that red line. Okay. So if you go up from A, you have to go this way from B, if there is a solution. And of course there is. If you just went this way, when you come back, just go that way. And I guess I can draw on it because I have a number of these bricks. What I mean by going this way is you go up and into the right, and then when you come back, you just go down and to the left. And you didn't cross anywhere. So it is doable that if you go up, you must go from here to here. So it kind of becomes a new problem. How many ways can you go from this point to this point? And the answer is, well, you can go up 1, 2, 3, 4. So you go 4 up. And how many to the right? 1, 2, 3, 4, 5 to the right. So there's 9 moves, and you want to choose 5 of them to be to the right. There's 9, choose 5. That's how many ways you can go from, say, A prime to B prime. Now, just for the record, to go from A to A prime is only one way, and to go from B to B prime is only one way. So there are 9 choose 5 ways of going from A to B if you first go up and then you go to the right. Now, how many different ways can you go from A to B, where first you go to the right, and then at this point you then go up? That means how many different routes are there from here to here? From, we'll call it A double prime and B double prime. Well, you have to go 1, 2, 3, 4, 5 to the right. So you have 5 to the right, and you have to go up 1, 2, 3, 4. Not surprisingly, the exact number of rights and ups as there was for the other paths. Each path has to have 4 ups and 5 to the right. Maybe first you go up, that's 1 up, and then you go to the right, that's 1 right, and then you go a second right, and maybe you go up 3. So far you went up, well, let's count from A prime. So you only have gone up 3 so far, and you went 2 to the right. Maybe you go 3 more to the right, then you go up, and you arrive at B, and it was 5 to the rights and 4 ups. No matter how you go, it's going to be that way. So if you first go to the right, and then at B double prime you go up, it's still going to give you 9 choose 5 ways. So the final answer, which I'll put right here in the middle, well, we add these 2 ways of going. So we're going to get 2 times 9 choose 5. And 9 choose 5, well, that's 9 factorial over 5 factorial, 4 factorial. And there's the 2. 9 factorial is 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1, which is 5 factorial, over 5 factorial times 4 factorial. So 4 factorial is 4 times 3 times 2. I won't bother saying the 1. Well, the 5 factorials cancel out. 4 times 2 is 8, so the 8 cancels out. 3 goes into 9 3 times, so we are left with what we're left with. In the top, we have the 2, the 3, the 7, and the 6. In the bottom, nothing. So you have 6 times 6, which is 36 times 7, which is 210, and then 42. So 252 different paths from point A to point B where you don't cross. That is restricted to, if you're going up, you have to go here. You must cross this point. And if you go to the right, then you must cross that point. I mean, in theory, if you go up, you could arrive here. You just won't be able to return and not cross or touch. I mean, you can always go back this way. But in this point, you're crossing that corner, and that corner a second time. Okay, that completes this video. If you like math like this, type that makes you think a little bit about how to do a particular problem. Please subscribe to my channel and definitely expect to see more problems like this appearing on a regular basis. Tell your friends and teachers and classmates about my channel. Leave comments below and even leave problems that you would like to see done. Most of all, have a great day. Thank you.